This is part 2 of station 3, and this is a problem that's very similar to number 3 that we did in the last video. We have this x plus 17 divided by 4, and I'm going to create my boxes to kind of show what I'm going to do first, what I'm going to do second. And like we did in class, it's going to be easiest if we go ahead and subtract 3 from each side first. And on the right side, we're going to be left with 17. So on the right side, you have 17. And then on the left side, we're going to be left with x plus 17 divided by 4. The next step is to deal with the 4 that's in the denominator. So we're going to put a box around the x plus 17, leave that in the box. We don't want to touch that until we've gotten rid of the 4. So since x plus 17 is divided by 4, I'm going to multiply each side by 4 to cancel out the 4's on the left side. So on this left side, we're left with x plus 17 because 4 divided by 4 is equal to 1. So we have 1x plus 17. And then on this right side, when you take 17 and multiply it by 4, you get 68. And then the final step here is to subtract the 17 from each side. So we're using inverse operations to get the x alone. So we get x equals, and then we take 68 and we subtract 17, and we're left with 51. And that's your answer, 51. Let's go ahead and move on to problem 5. For this problem, again, we're going to box in the numerator because we want to deal with that last. So we're going to multiply the right side by 2 because x minus 8 is being divided by 2. And I'm going to show you more this time, this side, the multiplication of it, because I haven't really shown you the process of cancellation yet. So the numerators are 2 times x minus 8. When we multiply across, that's what happens. And then the denominator is 2 times 1, and we get 2. So hopefully you can see more clearly in this example that we have 2 divided by 2, and we're left with 1, and that's 1x minus 8, and 1 times x minus 8 is just going to give us x minus 8. So that's just to show you a little bit more in depth why those cancel. Hopefully that makes it make a little bit more sense. And then on this left side, we need to do the same thing. We need to multiply by 2. And again, when you multiply, it needs to be by the entire piece over here. So we have to multiply the 2 by the 30 using the distributive property. And we get 60. And then we also distribute the 2 to the 5x. The 2 is being multiplied by the 5x. And we get 10x. And then we're going to write the same thing here. So I'm just going to put little like quotes to show that it's the same thing. And I'm going to bring it all the way down here to where I simplified and got x minus 8 on the right side. So we have 60 plus 10x equals x minus 10. So now we're at a point where we can look at this. We've used the distributive property, and we can think about if we can collect like terms on the left side. There's nothing to collect on the left side. And then we go over to the other side of the equal sign and see if there are any like terms to collect. And x and negative 8 are not like terms, so there's no like terms to collect. The next step is to move all the variables to one side and all of the numbers to the other side. So what I'm going to do is I'm going to move the constants to the left side and the variables to the right side. And you could have chosen it the opposite way. You could have had the constants on the right and the variables on the left. It doesn't matter. So I'm going to go ahead and move this -8 to the left side so that it's going to be combined with its like term on the other side with the 60. And that'll put it on the constant side, removing it from the variable side where it doesn't belong. So I add 8 over here as well to maintain equality. And on the left, we get 68 plus 10x. And then on the right side, we're going to be left with x, because a -8 plus 8 is equal to 0. Now we need to move this 10x from the constant side over to the variable side. And to do that, we need to use inverse operations. So the inverse of addition is subtraction, so we subtract 10x from each side. On the left side, 10x minus 10x is equal to 0. So we're going to be left on the left side with just 68. And then on the right side, when you take x and you subtract -10x, we get a -9x. And the coefficient here, even though you don't see it, it's a 1, and 1 minus 10 is a -9. Last, this -9x is being multiplied by the x on the right. So the inverse operation is division. So we're going to divide each side by a -9. Over here, -9 divided by -9 is equal to 1, so we're left with just 1x. And then on the other side, let's think about this. What are the factors that 68 and 9 have in common, if they do in fact have anything in common? So what we're going to do is we're going to take the smaller number and we're going to write out the prime factorization of that number. So the prime factorization of -9 is -3 times 3. And then all we need to do is think about, all right, is 68 divisible by 3? And 68 is not divisible by 3, so that means that this is the simplest form, 68 divided by -9, when you're thinking of improper fractions. Next, we can change this answer so that it's a mixed number. So we think about it. 9 times 7 equals 63. 9 times 8 is 72. So 9 times 7, we get 63. And then 9 times 8 is 72, which is too much. We only have 68 to use. So that means that we can form a 7. And then 68 minus 63 is 5, so we have a remainder of 5/9. So this is a -7 and 5/9. So you could write it either way. And then let's quickly do this last problem. You multiply each side by 9. And on the left side, 9 divided by 9 equals 1. So we're left with -x plus 4. And then on this right side, we take 36 and we multiply it by 9, and we get 324. And then the 4 is keeping the x from being alone on the left side, so we subtract 4 from each side using the inverse operation. And on the right side, we're left with 320. And on the left side, we are left with -x, which is really a negative 1x. So to get x alone, the last step is to divide each side by negative 1, and we are left with x equals negative 320. And that's it for this station.